Dr. Jane Disney is the head of the Community Environmental Health Laboratory at the MDI Biological Laboratory. In a community survey she conducted, many expressed concern about the disappearance of eelgrass beds. Her survey results led her to study and begin restoring eelgrass in Frenchman Bay. She is holding a video camera that can be towed just above the seafloor. By analyzing the video, she can determine the eelgrass coverage. This is a bed of eelgrass growing just below the low tide line of Bar Harbor sandbar in April. Eelgrass is the only flowering plant that grows in Frenchman Bay. However, algae such as kelp and rockweed are found in the bay. Eelgrass provides many important ecosystem services. Eelgrass produces large amounts of oxygen in areas that could otherwise be anoxic mud patches that you can recognize by their sulfur smell. Additionally, eelgrass sequesters large amounts of carbon dioxide into the mud via its roots and rhizomes. This helps to counter ocean acidification. Eelgrass beds improve water quality by filtering pollutants and securing mud. Eelgrass is a habitat that many organisms rely on for shelter and food. This is a mussel spat found on a blade of eelgrass as seen through a microscope. The micrometer stands for micrometer, 1/1,000,000th of a meter. 100 micrometers equals 1/10 of a millimeter. Some other organisms which live on eelgrass blades within eelgrass beds are snails, sea stars, sea urchins, flounders, striped bass, cod, shrimp, and crabs. At the beginning of her research on eelgrass, Dr. Disney established that a change in eelgrass coverage had occurred. This map of Upper Frenchman Bay shows eelgrass coverage in 1996 in bright green and eelgrass coverage in 2007 in orange. Some of this decline may be attributed to mussel dragging by fishermen in boats such as the one shown. When a mussel dragger drags through an eelgrass bed, the grass gets uprooted and floats away. The local fishermen recognized the importance of eelgrass beds and have agreed not to drag in the areas where Dr. Disney is planting eelgrass. In 2011, Dr. Disney invited me to bring students to participate in her Young Environmental Leaders program during April vacation. This is the Waterville group that went that spring. All have since graduated from high school. One now has her degree in marine science from Maine Maritime Academy. Another is in the Navy. One is working in Jackson Hole, Wyoming for a forestry company. The rest are in college. One part of Dr. Disney's research that our group worked on was mapping the eelgrass beds using handheld GPS units. To do this, some students had to enter Frenchman Bay, which was frigid in April. Even when wearing a wetsuit, the water is cold. At the end of the week, this student said, "Before, when we were learning about environmental protection in school, it kind of felt like it was really distant. But doing this kind of made me feel like I can make a difference." The students also recorded information about the eelgrass beds using quadrats. The quadrats were thrown at random, and information about the plants and organisms found in the quadrats were recorded. Data included the number of plants, their length, and substrate types. This information helps give an idea of the health of eelgrass beds. The students measured the water quality for parameters including dissolved oxygen, salinity, turbidity, temperature, and pH. While eelgrass does improve and protect water quality, in other areas, poor water quality has led to a decline in eelgrass beds, so this is an important parameter to study. In 2011, we built the first batch of biodegradable grids for transplanting eelgrass. The grids are made of pine and jute twine with cotton bags filled with sand to weight them down. Previously, Dr. Disney had used metal grids weighted with bricks. This required removal of these each year, destroyed some of the plants. The students in the foreground of this picture is now entering his senior year in engineering at UMO. The group returned to MDIBL in June to deploy the grids they made. Here, eelgrass plants are being tied to our biodegradable grids and to pieces of lobster pot that are weighted down with bricks. The young man smiling at the camera graduated this spring with a master's in mechanical engineering from Lehigh University. These are wooden grids with eelgrass attached, being transported to Berry Cove to be planted. The eelgrass must be tied to the grids as eelgrass plants float when they are uprooted. When asked about her experience, another student said, "I just like how we're doing work that is taught like it is adult work, but really it's work kids can do. I think it should be a school thing that everyone does." It's a really good experience. The photo on the left is from August 2012, showing members of the Waterville research team establishing what was to have been our research site. The PVC pipe is being placed to mark the location of the transplanted eelgrass. The photo on the right is the same location in Berry Cove at low tide in August of 2013. 1 year later, eelgrass was missing from all the Upper Frenchman Bay. To try to get a handle on the number of green crabs Near the eelgrass beds and former eelgrass beds, we deployed 10-meter lines and tossed a quadrat along the line. We dug within the quadrat looking for crabs. We recorded the size and sex of each crab we found. We found a lot of green crabs in 2013. We returned in August of 2015. Fellow Waterville teacher Heather Blanchett joined me in leading the team. As you can see, not all of our work is outside, nor is it always super serious. The admission counselors at Rochester University said that this experience was what set one of these young men apart from the other applicants and helped him gain admission to their biomedical engineering program. His brother will be studying engineering at UMO. In 2015 and 2016, we again spent time looking for crabs and monitoring water quality and planting eelgrass. The students have spent a week at MDIBL, have gone on to do many remarkable things. Examples include students spending a week up at MDIBL as summer interns, spending 8 weeks as a summer intern, students that have gone on to study engineering. Quite a few people have studied engineering. Of course, the chance to spend time on beautiful Frenchman Bay is also fantastic. Floating on a boogie board over eelgrass beds while wearing a mask and a snorkel inspires appreciation of the beauty of nature. This is one of the favorite activities of students in our summer trips. Since 2011, 32 Waterville students have been involved in experimental design, data collection, and data interpretation as part of this program. Thank you to Dr. Jane Dizzy for all of her work, and thank you to the following that have helped pay for this: Mount Desert Island Biological Laboratory, Center for Ocean Science Education Excellence, the Environmental Protection Agency, NASA through the Maine Space Consortium, Martin's for allowing us to do a bake sale the last 2 years, Peter Tibitot, Assistant Superintendent of Waterville Public Schools, Brian Laramie, Principal of Waterville Senior High School, and the Green Team of Waterville Senior High School. Thank you.